So I'm just going to do some more questions of electrophilic substitution, though. So I guess the mechanism for that explained. We did this why no addition takes place. ठीक है. What's the mechanism with Br plus one? Okay, you have a benzene, right? So I'm just going to do some more questions. And a Br plus one comes in and takes away electrons from the benzene, and it bonds with that bromine. And in the next step, the H is the one that loses electrons, and your benzene becomes complete again. ठीक है? Is this clear?
यस सर, बस सर कौन सा बी आर वो होगा, तो उसमें एरो हम कहीं से भी लगा सकते हैं बी आर पॉजिटिव की तरफ?
हाँ. या मतलब उस कार्बन से. I mean, from that carbon, the one that you're aiming to bond with. ठीक है? And you add AlBr4 minus one, that, so you get HBr, or AlBr3 is formed. ठीक है? Is that clear? So we can show how the catalyst is reformed. So it's basically the H plus one that breaks away, and it joins with AlBr4 minus one and combines with it and forms HBr, and AlBr3 is formed back again. ठीक है? Clear है?
Yes, sir.
अच्छा, इधर वो suggest, हाँ ये आ गया. Suggest why bromination of phenol occurs more readily than bromination of benzene. तो ये हमने किया था कि I told you कि activated benzene, right? वो phenols वाला क्या है? 2,4,6 directing. Nitration of phenols, right? So I told you कि when you have phenols or you have phenylamine, the lone pair overlaps. You have to write this entire thing, ठीक है? Uh, has large electron donating effect. Lone pair on oxygen in OH group overlaps with benzene's pi electron cloud. ठीक है? That's why the electrophile is going to be more strongly attracted. You don't need a catalyst for bromination. And for nitration, you just need dilute nitric acid. That would be sufficient. Okay. So just 2 marks. Okay. So you're going to write that the lone pairs on OH, but again, lone pairs on oxygen in OH, they overlap with benzene's pi electron cloud or the benzene ring, which increases its charge density. Leading to stronger attraction, and that leads to stronger attraction for electrophiles. Is that clear?
Yes, sir.
ठीक. That's the next one. There are 4 different carbocations with the same formula C4H9 plus. One structure is given. The table suggests the structural formula of 3 other carbocations. So you have to draw isomers C4H9 plus 1. So the other carbocation could be, I'm going to draw the entire structure. So 4 carbon atoms. So there are 3 H's, 2 H's. One of the H from the middle might be lost, or wood might break away, which leads to this thing getting formed. Is that clear?
Yes, sir.
यस सर.
अच्छा, और क्या हो सकते हैं in a straight chain? If I put the carbocation over here, then it's the same thing, right? Clear है? So Now I need to draw a branched one. So C4H9, right? So I'm going to have three H's. Okay, there's going to be three H's over here as well. And this one over here could be the carbocation, right? Or I could have a carbocation on the side that this carbon would be losing an H. ठीक है ये clear है? Is this clear?
Yes, sir.
So I have C4H9 plus. So there are four different types of carbocation. ठीक है, so अच्छा, which one, if although there's no further question, which one of the carbocations do you think is the most stable one?
Sir, structure 3 one, the third structure 1.
हाँ ठीक है, the tertiary carbocation, that's the most stable one. ठीक है, because of more electron donating alkyl chains, the positive charge density is going to be very, very low. And the most unstable one, so this one is a tertiary carbocation. This one I think is a 2-degree carbocation, a secondary one. This is a first degree primary carbocation, and this one is also a primary carbocation, right? So these two are the ones that are unstable. They're the ones that are more difficult to form. ठीक है, clear है?
Yes, yes, sir.
So we've got this question, and he says, construct an equation for the formation of NO2 plus 1. This is nitration, right? Concentrate nitric acid, sulfuric acid. So he's asking for the equation where the electrophile gets produced. ठीक है, nitration क्या था? Where was nitration? That after this. In nitration, what happened was that you had two steps. Step number one was that these two will react and they would form the NO2 plus 1 electrophile. So you need to remember the equation. And then the NO2 plus 1 would attack the benzene and you would have the reaction. Okay? So you got to remember the equation. So it's 2 sulfuric acid and 1 nitric acid. And together they're going to form NO2 plus 1 and 2 HSO4 minus 1 and a hydronium ion, which is H3O plus 1. Okay, that's going to get formed as well. And next step, he's asking for the mechanism. So that's the mechanism that you already have NH2. The NO2 will get attached along with the H that's already there. And at the top, there's a carboxylic acid group. Okay, so right at the top, there's a carboxylic acid group. And next step, the H loses the electron. And where does the H go? Look, right now, they're not saying where the H goes. It just forms an H plus 9. But the H would eventually, as I state the name of the mechanism, that's obviously electrophilic substitution. Where does this H plus 1 go? It eventually goes and bonds with the HSO4 minus 1. That's the next one. State the role of FeCl3 in this. It's a catalyst. This is chlorination happening. It's a benzene, and the chlorine is getting attached to it. FeCl3 is your catalyst. Okay, we've got state what is seen when aqueous bromine is added to phenylamine. So what you're going to see when aqueous bromine is added to phenylamine, not the reaction, what you'll just see. So when you add, remember phenols and phenylamine, they have kind of the same reaction. So the first thing that's going to happen is you're going to see a white precipitate. You can remember phenylamine, it's going to be exactly the same. Whether it's OH or NH2, the reaction will be exactly the same. I mean, you can put an NH2 over here instead of the OH over here. So you'll get a white precipitate, and the bromine, red brown bromine decolorizes, but a white precipitate also forms. So there are two observations. So Br2 red brown bromine decolorizes. Okay, that's one. And a white precipitate forms. Is that clear?
Yes, sir.
As I suggest what is seen when aqueous bromine is added to ethylamine. Nothing would be seen. There's no reaction like this. I mean, ethylamine is a simple amine. It's just two carbons with an amine group. The bromination reaction happens for phenylamine, not for alkylamine. As I draw the product formed when bromine is added to phenylamine, excess of bromine. So remember, it was a highly activated group. It was a 2,4,6 directing group. So the bromine will get attached to all C positions, 2, 4, and 6. And this is 2,4,6 tribromo. Okay, so it's 2,4,6 tribromo phenylamine. Is that clear?
Yes, sir.
So what else? This is the whole alkylation thing. He says that the AlCl3 catalyst produce there's a there's chloromethane. Okay, there is CH3Cl, and it reacts with AlCl3, and he says that it produces this carbocation with a positive charge. And the other thing is obviously going to be it's going to be AlCl4 minus 1, right? And the whole mechanism will be exactly the same. So the CH3 bonds and the H bonds. And the H then gives the electron back. So that was alkylation. State the reagents and conditions for step one. Now that's a tricky. I mean, you've studied this in AS. Step one, he's talking about step one. Do you remember कब होता था when the bromine gets added to the carbon chain? It's not getting added to the benzene. So that means this is not electrophilic substitution. This is not a reaction for benzene. Nothing is happening to benzene. How do you attach a halogen to a carbon chain? वो किस तरह होता था? What was that reaction? कोई याद है? Do you remember
Electrophilic substitution?
any free radical substitution?
Oh, wow.
Oh,
UV light, ठीक है?
Yes,
You
yes, sir.
you wanted Br2 and UV light, right? So keep this in mind, ठीक है? This is not electrophilic substitution. This is not a reaction for benzene. This is just a random bromine getting added to the carbon chain, and that happens under UV light. That's a compound Q. That's a reaction we haven't done, so forget that. So we've got this reaction to again. This is alkylation. ठीक है? The Cl is going to get knocked out. So this benzene will get attached to CH2 thrice. So that's CH2, CH2, another CH2. One second. Just hold on one second. अच्छा सॉरी, आवाज आ गई।
ये
Yes, sir.
अच्छा, ये CH2 और फिर वो कार्बोक्सिलिक एसिड, राइट? इज दैट क्लियर? कि इट्स अ कार्बन चेन गेटिंग अटैच्ड टू द बेंजीन, राइट? इज दैट क्लियर है ना?
यस सर।
एंड ठीक है, दिस इज अ रिएक्शन दैट वी डिड नॉट डू। he's saying write an equation for the formation of the electrophile. So वो Cl gets knocked out, right? When the AlCl3 reacts with this thing, Cl, अच्छा, with the entire thing, ठीक है, Cl, बल्कि he's saying कि just use RCl. So we can use RCl. So AlCl4 -1 gets formed and the carbon chain gets positive. It becomes a carbocation. ठीक है, clear है?
Yes, sir.
यस।
अच्छा, बाकी your mechanism exactly same, and R is getting attached. It's the same R+1 that's getting attached. You got to draw the whole thing. ठीक है, same thing. ठीक है, no difference. Uh, what's happening here? Okay. अच्छा, ये वाला बाद में करेंगे. This is because there are too many reactions involved. Um, अच्छा, इसमें नहीं, again too many reactions involved. अच्छा, this one. There's this thing happening. ठीक है, so वो कह रहे there's a reaction one and there's a I guess there's a carbocation that's getting formed. ठीक है, I mean something positive charge getting formed, which goes and then reacts with benzene. तो वो he's saying कि suggest a mechanism for reaction number two. So it's just a simple benzene, right? Yeah, it's just a simple benzene. That's it. So you got a simple benzene, and this thing which is C double bond O+1, and it's got a Cl as well. So you have to suggest the mechanism. So it's pretty obvious. It's electrophilic substitution that's happening. तो क्या होगा? It's going to be this thing will bond, and it's going to have an H. Or next step में the H loses electrons. ठीक है, clear है?
यस सर।
Yes, sir.
अच्छा, वो कह रहे ignore the effect of this. I said this is obviously, we can complete a table by drawing the structure of the organic product formed when tyrosine, this one. वो कह रहा है ignore the effect of this thing. अच्छा, it's a phenol. Phenol कौन सा directing group था? 246, right? So if you add a bromine to it, और वो इतना activated होता है कि the bromine is going to get added to all three positions. लेकिन it's not going to get added to the third position क्योंकि वहां पे a carbon, अच्छा remember carbon, a carbon chain is already attached, so you don't add it over there. ठीक है, is this clear?
Yes, sir.
NaOH again वो वाला रिएक्शन नहीं किया हुआ, कोई और देख लेते हैं कि अच्छा, बाकी it's kind of we've done enough questions. ठीक है, similar to this. um हाँ, ये कर लेते हैं कि state the CCC bond angles uh, and the hybridization shown in benzene. Benzene में क्या होता है? What's the bond angle and what's the hybridization?
Hybridization is sp3
नहीं, sp2 होती है, डबल बॉन्ड होता है.
or sp2 double bond.
और एंगल्स क्या होता है? That's 120 degrees, right? अच्छा, बाकी सेम, एवरीथिंग इज सेम. और कोई डिफरेंट क्वेश्चन है? um, अच्छा, वो आर आर का ना, फिर से he's doing the bromination of R. So the bromine will get added to, it's a phenylamine. ठीक है, phenylamine is highly activated, so bromine is going to get added to these two positions. ठीक है, 2, 4 and 6. Not the fourth one because there's already a carbon chain attached. ठीक है, is this clear?
Yes, sir.
अच्छा बाकी I guess same mechanism, same. Remember, you देख लिया it comes a lot, right? Electrophilic substitution. It's
Yes, sir.
in almost every paper. Draw the major product of the mononitration of benzoic acid and of phenol. Major product, right? Mononitration. Mononitration means single nitration. So if it's benzoic acid जो था ना, that was an electron withdrawing group. So in the case of benzoic acid, I guess it's going to be 3,5. So the NO2 will get attached to position number 3. And the case of phenol, ठीक है, phenol is highly activated, so it should get attached to all 3 positions. But since he's using the term mononitration, so it's either going to get attached to position number 2 or it's going to get attached to position number. The nitro group will get attached to position number 4. ठीक है, clear है?
Yes, sir.
Then ठीक है. Um, क्योंकि a lot of questions are linked with other things. Same exact. अच्छा यहाँ पे he might change things a bit. लेकिन remember it's exactly the same mechanism. ठीक है? It's exactly. I mean the Cl is getting attached to over here. This is not like a benzene, but it's kind of the same as benzene. So you got to draw the exact same mechanism. ठीक है? तो बस ठीक है. So we'll बस मैं ये बता दूं because very few people are here right now. So the next thing that we are going to do is, अच्छा we're done with electrophilic substitution. ठीक है? So that is completely done. So the next thing that we're going to do, that will be called hydrolysis, the comparison of hydrolysis. ठीक है? So it's the comparison of hydrolysis of chlorine substituted compounds. अच्छा अब इसमें ये कि there'll be 3 chlorine substituted compounds. There's going to be chlorobenzene. ठीक है? So there's going to be chlorobenzene, and there's going to be halogenoalkane, any type of halogenoalkane, and there's going to be an acyl chloride, which is ठीक है? So 3 compounds. So फिर we'll do that in the next class. ठीक है? Comparison of which one is going to get hydrolyzed easily and which one is going to be difficult to hydrolyze. ठीक है? वो फिर नेक्स्ट क्लास में कंटिन्यू करते हैं. ठीक है?
Okay, sir.
Correct. Okay, take care.
Okay, sir.
Okay, sir. Allah Hafiz.
And after, sir.
Thank you, sir.